These are the notes for section 1.2. There are several learning objectives for this section. The first is to graph equations by plotting points. Second is to find intercepts from a graph. Third is to test an equation for symmetry with respect to the x-axis, y-axis, and origin. And lastly, we need to know how to graph key equations. So there are 3 examples here. We're going to go over each one. We're going to start by the first example. And the first example says, determine whether the points 0, 3, negative 2, 0, and 2, 7 are on the graph of the equation. Well, the first thing we need to know about this is that all points are in the form x, y. Once we know that, we can go ahead and either substitute x or y. So let's go ahead and solve for y. So if I know that x in the first case is 0, then we're simply going to plug in 0 for all the x's. So we have 0 cubed minus 2 times 0 plus 3. So this gives me 0 minus 0 plus 3, which is y equals 3. And we notice that, yes, this is good. So for this one, it is yes. So now let's look at a different problem. So now we have negative 2, 0. So now we have y equals, and now all of our x's are going to be negative 2. Please remember that that must go in a parenthesis since it is negative. So we're going to go ahead and simplify. Negative 2 times negative 2 times negative 2 is negative 8 plus 4 plus 3. So that gives me y equals negative 1. So in this case, negative 1 is not what we have here. So the answer to this point is no. And lastly, let's check the last point. We have y equals, and this time we're using 2. So now we have 2 cubed minus 2 times 2 plus 3. So we're going to simplify. 2 cubed is 8 minus 4 plus 3. So now we have 8 equals 7. And so if we notice, this point does indeed match the negative 7 here, so this answer is yes. But I also want to look at this problem from a slightly different approach. So I'm going to shrink this screen down some and slide it over. And I'm going to bring up a calculator. The nice thing about teaching online is that you can see all different methods. So what I've gone and done essentially is I have put the equation into our calculator already. And we're going to look at what the graph looks like. And here's what the graph looks like. Well, we're not so concerned with what the graph looks like, but whether these points are actually part of the graph. So we're going to press second graph, and now you'll notice that we have a chart. But in this case, we don't have everything set up properly. So we're going to make sure that our table is on auto so we can see all of the values that belong to the graph. So the first value we want to check is 0 for x, and notice that y is 3. So again, this goes back and checks out with the first point, yes. Now we need to go to negative 2, so we're going to press up, and it says negative 2 is negative 1, which does not match, which is what we found. So it is no. And then lastly, we have 2 and 7. So yes, this point matches. So a lot of times it's very easy to check your work. I will accept work that's done on the calculator as long as you've told me what the steps are for that problem. For the next equation, it says find the intercepts of the equation y equals 2x minus 1 by plotting points. Well, the first thing we probably need to do is substitute x equals 0 and y equals 0. Then we'll find out what those values should be. These will give us the intercepts. So this will be the y-intercept, and this will be the x-intercept. So let's start with x equals 0. So we have y equals 2 times 0 minus 1. So we have y equals negative 1. So we know that the y-intercept is negative 1. So let's go ahead and plot that point. So if it's the y-intercept, remember this is the x-axis and this is the y-axis. The y-intercept is going to be negative 1. So now we need to find the x-intercept. So now we're going to substitute 0 in for y and solve for x. So we want to add 1 to both sides. So now we have 1 equals 2x. We want to divide by 2, and we see that x equals a half. So we're going to come over here to where x would equal a half and put our point. And now we want to make a nice line going through those points in green. And the same way down here. And there would be our line. Please remember that all lines should have their arrows on the end. So this is how we would do it by plotting points. Now we're going to look at the next problem, and it says list the intercepts for the test list the intercepts and test for symmetry for each problem. So first we're going to tackle the issue of intercepts. So remember we want to find the x-intercept and the y-intercept. So the x-intercept is going to be when we place y equal to 0. So we have 0 squared minus x minus 4 equals 0. Well, the 0 squared doesn't matter, so first thing we want to do is add 4 to both sides. So now we have negative x equals positive 4, and we want to divide by negative 1, so we have x equals negative 4. That would be our x-intercept. Now we want to find our y-intercept. And we find our y-intercept by by substituting 0 in for x now. So now we have y, oops, let me move that down some. So now we have y squared minus 0 minus 4 equals 0. Well, again, the 0 doesn't matter, so we want to add 4 this time. And we have y squared equals 4. So now we're going to take the square root of both sides. So we get y equals plus or minus 2. Please remember anytime we take the square root, we get a positive and a negative. So we have 2 here. We have y equals 2 and y equals negative 2. Okay, so now we're going to solve for the x-intercept for the other problem. So to do that, we're going to set y equal to 0. So we have 0 equals x divided by x squared minus 4. So we want to multiply both sides of the problem by x squared minus 4 to cancel out the denominator. So now we have 0 equals x. So the x-intercept is 0. The next one we want to do is find the y-intercept. And to find the y-intercept, what we're going to do is substitute y in for, or 0 in for x now. So now we have y equals 0 over 0 squared minus 4. So we have y equals 0 divided by negative 4, which is just 0. So in this case, we have y equals 0 as the y-intercept. So since it's x equals 0 and y equals 0, we can tell it's at the origin. So the last thing I want to do for this problem is I would like to look at this problem on the calculator. So we're going to go back to y equals and clear out what we have. And this time we're going to use y squared minus x minus 4. So before we do that, we can't put this equation into the calculator right now. So we need to rearrange it. So we're going to bring everything over, so just y is by itself. So we're going to add x and 4 to both sides. So now we have y squared equals x plus 4. And we're going to take the square root of both sides, so that gives me plus or minus x plus 4. Now we know what we can put in our calculator. We can put in the square root of x plus 4 and a secondary equation of negative square root of x plus 4, because we have to have plus and minus. So when we look at the graph, we see that it makes a sideways U or a sideways parabola, and we want to test for symmetry. So is there any way that I can split this graph so that it makes a mirror image of each other? Well, I know that, oops, if I come to this equation, let me do it. I can split it right down the middle, right here, right where my cursor's going. So my line of symmetry would be the x-axis. So yes, this one does have symmetry. So we'd come back here and write yes, symmetry on x-axis. Now let's look at the second equation. This one's already in the correct form, so we simply plug that in. So it's important to remember that we need to use parentheses. So we're going to clear out what we have. And now we have x divided by parentheses x squared. Oops, it's not an x. X squared minus 4. And we're going to close off the parentheses, and we're going to take a look at the graph. Alright, so now we want to decide if there's any way that I can split this so that I would have the same thing on either side of the line. Well, I can tell right away that if I split this right here, right up and down this line, that it would not look the same, because this would be over here and this would be on the bottom. So that wouldn't work. If I split it across the x-axis, we notice that that won't work either, because now we have one on the top and one on the bottom. But if I split it across the line that goes like this, which is the line y equals x, then we would have exact replicas. And this would mean that it is symmetric about the origin. So in this case, yes, we do have symmetry, and it is with respect to the origin. So yes, origin, symmetry. So one more thing on this quick note, just to tell if it has origin symmetry, you can do it this way. Think about flipping the equation over the x-axis first, and then the y-axis. So let's just look at this piece. If I took this piece right here and flipped it over the x-axis, it would now be up here. Likewise, if I flipped it across the y-axis, now it would be here. So this piece absolutely checks out to be symmetry about the origin. So let's check the other piece. So again, if it's symmetric about the origin, I should flip it over both axes. So if I flip it over, now it would be over here across the y-axis, and if I flip it across the x-axis, it would now be up here. So we do have symmetry about both origins.